All right, sixth grade, we are to the end of our little battle week. It's a small week for us in regard to the battle. Can promise next couple lessons, I'm going to move into other ideas. But last kind of piece we have to get, subtraction of integers, and the battle rages on. L99, oh, we are so close, and you are the first. As long as everything continues normally, you will be the first to reach 100. I am so proud of each and every one of you. Let's dive in. So I had left the last lesson with kind of a statement, and I want to deal with that right now. So let's look at a couple situations, though. So we have 5 minus 7. And again, minus, negative, what is it? We've seen that this could be written with greater complexity, such as 5 plus negative 7. And this leads us to one of our new Pavlovian responses, if you don't already have it in. And it's this. And I wonder if someone could help me fill it out here. So we say that subtraction is something of a something number. Can anyone get me through the first something? Yes, go ahead. Subtraction is addition. Well done, yeah. Good job. Now, I actually said that in the video, so that just means that you listened well. I'm impressed. Now, what I didn't do in the last video was complete this statement. Can anyone take us all the way through? Okay, go ahead. Subtraction is addition of a negative number. Oh, wow, you guys are on it today. I am impressed. And this is true. So again, I always think of it like, okay, so notice how I have a plus adding a negative. And we know that this is exactly the same as this phrase, as 5 minus 7. It's almost as if the subtraction sign, or the negative sign, became shorthand for this idea. The subtraction is merely adding a negative number. That's all it is. We recognize, even asking us battle questions, that the answers to both of these will be the same. Because I'd say, is it a battle? Yes, it is. Who's going to win? The negatives. By how much? 2. And then here, 5 minus 7. Is it a battle? Yes, it is. Who's going to win? The negatives by 2. And we've been exploring how there's levels of complexity. We can write this. But really, all it comes down to is like, look, subtraction, yes, it exists. But it doesn't exist outside of or separate than addition. In fact, subtraction is addition of a negative number. And the quicker you can get that in your brain and a full understanding of it, the better off we'll be. Let's look at this, because this third installment here is going to open up a couple ideas we have to get into. One is written right here. You see negative 3 minus negative 2. And this introduces us to something called the inverse of the inverse. And the inverse of the inverse is a property in mathematics. The way they show it algebraically is this, that the opposite of negative a will ultimately become positive a. Right? Just regular A. And that's what we have going on right here. The inverse of the inverse. And so what I want to do in that situation is realize what it becomes. We say down in the inverse of the inverse here that the opposite of negative A becomes positive A. Well, that's what's happening here. The opposite of negative 2. And so what we're going to do is basically rewrite this. That negative 3 has it's not changed at all. And what it's become is being added by 2, or negative 3 and positive 2. Then once I've dealt with that, I want to ask myself those battle questions. Is it a battle? Yes. Who's going to win? The negatives. And by how much will they win? Clearly negative 1. And this inverse of the inverse is a really important idea. And it becomes kind of a little practice that you do. So if we had something like this, 8 minus negative 10, what we see right here is that same thing, that inverse of the inverse. We're going to write that down again, because essentially what you do when you have two negative signs right next to each other with only a set of parentheses in between them is we're just going to turn them both into a positive. And I want you to write that down. So for the inverse of the inverse, what you do is you change the two negatives into a positive. Into positives. And it's just a simple act that people who've learned this, when they see a negative right next to a negative, they just plus plus, right? Now, I'm not saying if there's a negative of a negative of a negative. No, I'm just talking about 2, but this happens a lot. So once I've done that, and I could ask myself the battle questions, and I'd say, it's not a battle. 8 plus 10 is clearly 18, and I'd box that up, right? Another example. We have -6 minus -2. Again, is the inverse of the inverse here? Yes, it is. And we should just take 2 immediately going positive, positive. You don't have to erase anything. It's just that boom, boom. Now, another important thing, sometimes people, when they learn about the inverse of the inverse, they go a little crazy on it and they just start changing everything. No, 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 no. Math is a reality. You got to read your math. Right there, this point that I just marked, that's the inverse of the inverse. However, this guy, that negative, does not get affected. This is not affected at all. There's no negative sign next to that negative sign. So it's going to be right next to, as we see near the 2, or between that -6 and the 2. So then, again, I don't find a great need to rewrite in this situation. All I know is that I have a -6 going up against a +2. That's clearly a battle. In that battle, the negatives will win, because there's a 6 going up against a 2. And how much will they win by? 4. So -4 would be my response, right? Let's look at this situation. As we've seen before, when we have more than one, we want to kind of collect all positives and collect all negatives. But before we do so, part of the trick is like going, okay, well, which one's positive, which one's negative? First, hopefully you see right away the inverse of the inverse. And what we want to do in practice is when we see these 2 negative signs right next to each other, only being separated by, at best, a parentheses, I'm just going to go boop, boop, right? Now, let's look over here. What's going on over here? Now, this is something I call the distributing the negative. And distributing the negative, we've talked about the distributive property, is a multiplication thing. But we can write this out kind of using that algebraic way. If we said, okay, so if I have the opposite of positive A or negative positive A, which is what we've got going on in the purple there, then what I can say is that that will be equal to negative A. And that's just how it works. So what we're talking about here is that negative +6 ultimately becomes just a -6. So we're going to go ahead and rewrite this one. I would rewrite it. So I've got this +2, I'll just write 2. Then I've got this -5, I'll just write -5. And then remember what happened in the purple there. Well, that's distributing the negative. So that negative times that positive essentially becomes negative. And so I'll write -6. Then I'm going to collect my negatives. -5, -6, that'll be -11. Then I have one positive. I ask myself if it's a battle. Yes, it is. Who's going to win? The negatives by 9. Boom. Yeah. All right, a little bit more on this idea. So here we go. Sometimes there won't be any parentheses. Is there still inverse of the inverse? Absolutely. So whenever you see these 2 negative signs right next to each other, your first step, simply boop, boop, boop. Yeah. Then I ask myself, is it a battle? Yes, it is. Who's going to win? Obviously, the negatives will win that one. I got 10 going up against 6, and they'll win by 4, so it's -4. Yeah. Another example might be something that looks like this. So I have in parentheses -3. Then I have minus +5. And again, this is not the inverse of the inverse. This is what? Well, this negative and this positive are being multiplied, essentially. And therefore, we call it distributing the negative. And what we know what's going to happen with that 5 is the end result that it will be negative. I do generally rewrite these because it's a little convoluted. So I'll write -3 minus 5, right? Because I'm distributing that negative. Is it a battle? Nope. They join forces at, and again, there'll be, I'm a UCLA fan till the day I die. They're negatives till the day they die. They're not dying today. They're joining forces at -8, and I box that. Now, this actually opens us up to something that I wish Saxon gave us out a little bit, and it's been assumed information I had of you, but then we've been stuck. So we're going to do with it today and make sure that we are moving forward correctly. I need you to write this down, and the proper interpretation of this would be simply a positive times a positive. Just below it would be a negative times a negative. Now, there's other situations that can occur, but we're going to do that in a different color here. So how about a positive times a negative, and then a negative times a positive? So these two are grouped together to be referred to as like sign multiplication, because they're like signs, right? I got a positive times a positive, or I have a negative times a negative. These, as you might imagine, are called unlike signs multiplication. And because I got a positive times a negative, or a negative times a positive, they are unlike signs. Now, the end result of like sign multiplication, we already know that a positive times a positive is clearly a positive. And a thing to know that we group these together because a negative times a negative is, yep, you're right, a positive. That's how reality is. Let's look at unlike signs. Well, we know that unlike signs will be a positive times a negative, and the end result to that, either way you go, is always, 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 I'm sure you can guess, a negative. And that's kind of what's happening with these examples we've been looking at. So if I look at 8 minus the opposite, minus the opposite of 3, this is called the inverse of the inverse. But think about what's really happening. So this negative is being multiplied by this negative. It's actually -1, but we don't have to worry about that right now. And what does that fit? Well, that fits this pattern, right? A negative times a negative. And we know the end result is a positive. And that's why we quickly go positive, positive. Because we know a negative times a negative is a positive. And this would obviously be 11. Yeah, that's not the worry right now. Now look at this other situation we saw today. So 9 minus a positive 12. Well, again, what's technically happening there is multiplication. This negative is being multiplied by that positive. How do I know it's multiplication? Well, because of the use of the parentheses there. It's actually a sneaky one in there. So what situation does that fit? Well, that fits this situation, right? And we know that unlike signs, a negative times a positive always results in a negative. That's why in a rewrite, I would say 9, positive 9 clearly, minus 12, negative 12. Is it a battle? Yep. Who's going to win? The negatives by how much? 3. Box it up. Yeah? All right. Some nice big ideas today. I love the battle. You know that. I give you those battle questions so you always ask yourselves them. I won't be able to ask yourself. I can't ask you when you're doing your homework or on your test. It's your job to ask yourself. So L99 does translate to homework 99. This is a Odin's Day. So happy Odin's Day. As I mentioned, we're not testing this week. We'll be testing next week. What else? I feel like there was something else. Oh, just for the remainder of the week, I promise, though battle concepts might come up, they are not the focus of our lesson. Take good care. Reach out if you need me. Bye.